Welcome to Biomechanics on Our Minds. My name is Melissa Boswell.
And I'm Hannah O'Day, and we're PhD students at Stanford University.
This podcast is brought to you by the International Society of Biomechanics.
It's
time for Boom.
Welcome to Boom, where we have
Biomechanics on our minds.
Boom.
Boom.
Boom, boom, boom,
Boom, boom, boom, boom.
boom.
Welcome back to Boom. Today we're talking with Jonathan Samir Matthis, who is a tenure-track professor of human movement neuroscience in Boston, Mass., hailing from my hometown. And he's also the founder of FreeMoCap Foundation. And we're so excited to have you, Jonathan. Thank you so much for joining us.
Lovely to be here.
So can you tell us when you first knew that you wanted to be a biomechanist?
I mean, I guess I'm a biomechanist now, but my my first degree was in philosophy. And I consider myself more of a neuroscientist than a biomechanist. I studied the part of neuroscience where we move our bodies around. It's a bit of the path is a meandering one, but it went from philosophy to kind of like visual neuroscience, which got me into specifically studying the visual control of locomotion. And then I kind of realized at that point that you can't really, plenty try, but you really shouldn't study the visual control of movement if you don't know about the actual movement. And if you want to know the actual movement, you're probably going to have to talk about physics. So I kind of, backed my way into biomechanics just as sort of the need arose in my early grad school as a philosophy major trying to learn how to do science and kind of realizing it's like, oh, there's this whole area that I need to know about. And because I didn't know anything, it was just as easy to learn half of vision science and half of biomechanics as it was continue as a normal, regular trained grad student.
Yeah, I can see that connection there between neuroscience and then studying human movement. I'm curious about the connection from philosophy to neuroscience.
Well, it wasn't necessarily planned. I mean, I was studying sort of philosophy of mind, philosophy of science in my, undergrad days, and always kind of had a fascination, in retrospect, a fascination with kind of like that interface between like, what am I and what is the world, which kind of winds up being, if you really want to pare it down into like a studyable question, that winds up being perceptual motor control, mind-body problem stuff. I actually applied to go to grad school for philosophy and by grace of God was not accepted into any of the programs I applied to. And then wound up working at an autism research facility for a year and was like, oh, wow, data's cool. You can like say things for people.
Yeah.
Like I do, another slew of graduate programs in cognitive science was the tag I was looking for. And I was planning to study language and then accidentally one of the places I applied for didn't have a language person. So I didn't notice that until I was like writing the personal statement. And I was looking through the list of like, well, what else do they got here? And there was a guy named Brett Fajan. He studies visual control of locomotion. And sounds pretty cool. And that's the only one that I got into. So now I found myself studying visual control of locomotion. And what is that, 13 some odd years later, here I am with skeletons in my office and robotics and a professorship and whatever.
Well, it's cool to see you go and be open to all those different parts of your journey. Like you said, by the grace of God, you weren't in philosophy and you really listened to the different things that I think.
And I'm like, I haven't hit the ground yet. So, here's hoping.
Well, you listed all the awesome things. We're looking at your, on video in this video call, your background of tools and skeletons. And I see like a drawing mannequin over there. Can you tell us? Clearly, you're a person of many interests, but we'd be excited to hear about some of the projects that you're working on right now.
So the FreeMoCap is the big one or whatever, but I also have kind of like a traditional line research because the FreeMoCap is like effectively a COVID project that's kind of, come to where it is. And I have like a traditional line sort of NIH funded research program on visual control of foot placement during locomotion. And that was sort of how do you get the visual information that you need to put your feet where it needs to go. And we have some projects brewing with that sort of fun, like augmented reality, projected ground planes and large scale traditional markered motion capture and integration with eye trackers and laser skeleton data types, which is what I call this like skeleton, like full body skeleton data with like lasers shooting out of the eyes, showing where people are looking. And I have Google, whatever my name is, I have videos on YouTube. And that was the traditional line research that I was sort of, fully planning to devote everything to. in roughly January of 2020, which is in retrospect a very funny time to do planning. In addition to that line, there is the FreeMoCap project, which is, free open source markerless motion capture system for everyone. And we're going to be talking about that, I know, but sort of like in that space, we're kind of working, there's like a bunch of stuff going on with it. One is like the core software development, like making the thing, making it good, making it better, making it work. Validation studies, sort of comparing it to my gold standard classical motion capture system recordings. Connections being drawn from that to like the animation community through open source softwares like Blender, and sort of making sure that the thing that's being built is useful for both for scientists and clinicians, as well as like animators and game designers, because they need mocap too. And also just like it's now at a place where like it works and you can do cool stuff with it if you know how to use it. So we're also doing cool stuff with it, which is pretty fun. So actually like using it to do researchy kinds of explorations. That about fills my day.
That's it.
Yeah. Sounds like enough to fill a few days. It's interesting to hear your start to FreeMoCap as a COVID project. I'm curious if you could share more about what during that time inspired FreeMoCap, and then when did you realize that this was turning into a bigger project than you expected and you wanted to commit more time to it and really see it advance?
I've been using motion capture for research since 2008 when I started with Brett Fajan in RPI, who's a wonderful person and a great advisor. And he had sort of, inherited this motion capture, like a Vicon motion capture system, which is probably the biomechanics angle is probably from that. So I've been working with mocap for a while. And specifically, I think like the start of the idea of FreeMoCap came in 2017, when OpenPose released their they had like a SIGGRAPH paper, what I consider to be like the first like viable markerless mocap thing that I have seen, which is, for you who don't know, it's just, traditional motion capture, marker-based motion capture, you put markers on the person and use specialized cameras to track them, and then yada, yada, expensive software. OpenPose released this demo video, and it was just raw videos and convolutional neural networks, trained on COCO data set or whatever, and it would draw a skeleton over the person, like, joint centers, connected dots, full body, hands and face of just raw video. And I remember seeing that thinking, oh, you could build a motion capture system out of that. And then proceeded to like forget about the idea for about 4 years. I mean, I played with it a little bit, but it was like limited, and like I didn't really have the technical skills or the time to really like focus on it. And then when I got to Boston and start my professorship in summer of 2019, which in retrospect is a funny time to start a professorship, I had a whole plan based on the traditional visual control of locomotion thing. And I was waiting for some equipment to come in. I was waiting for an eye tracker to come in. And the student that I had hired to work on the eye tracking part of it needed something to do. So I was like, hey, why don't you, pick up this old like OpenPose motion capture idea, get some GoPros and like work on that as like a stopgap till the eye tracker came in. And that was in January of 2020. And then the funniest thing happened. And all of my actual research plans went out the window. I had a whole plan. I had hired a bunch of people who were going to like build this equipment and do the foot placement thing. And then all of a sudden, the world shut down and I lost access to my lab for an unknown amount of time. So I was thinking, well, I don't know when we're going to get back. I don't know. And I got to do something. These students need, they need things to do. I need things to do. So what at the time was called the GoPro motion capture aspect of the lab became front and center. That's what we were working on. So that's kind of when it started, and then it has evolved in a very interesting way since then, where kind of like as the sort of the first phase of like the GoPro OpenPose mocap thing was starting to like achieve like viability, like we had reconstructed a skeleton. It was a lot of work, but like it did work. So it was like, oh, okay, this is a viable option. That was sort of roughly around like summer of 2020. So like George Floyd protests and like all sorts of like, world is burning kind of feelings, kind of just like, rising inequities and like, what are we going to do about it? And so sort of we were all in this like deeply introspective state about like, wait, like, what am I doing? Am I actually giving more than I'm taking? I don't think I am. So while I was sort of ruminating in those thoughts, I lived my life through the YouTube tutorials as a philosophy major turned like whatever science.
Yeah, self-education tools. Yeah.
The only real form of education. And I was like using, looking at like Blender, which is like an animation software. And I had been looking for a really long time trying to find tutorials on how to load motion capture data into Blender. And I wasn't finding it. And then I eventually found a tutorial series by a guy, like Royal Skies is his YouTube name. And he had a series about using a Kinect, like a Microsoft Kinect, to get motion capture data. And the long and short of that tutorial series is that it was awful. Like, it was a terrible experience. It was unreliable. Like, you're using like this old broken software. It's unsupported by Microsoft. There's no way to really link more than one of them together if you don't want to pay someone $1,000 for their software. And I realized that the reason why there was no available tutorials, free open source software using motion capture, is that people don't really have access to motion capture equipment. Cheapest options are like, minimum a few hundred if you want to do something like really don't want to use, and like 5,000 for like an IMU suit, or like beyond that, it's like, we're talking like 5-6 figures worth of equipment to get viable motion capture. In that space, I was sort of thinking, on the list of gross inequities of the world, like inaccessibility of motion capture is like pretty low down, but it is on the list. Like, and it became a thing that I could feel like I could focus on. It's like, okay, well, I'm going to provide this as like until that point, I was thinking like, this is a tool I will use for my research. And then that was kind of the first point of thinking that this is something that actually would be wanted and desired by the world at large and could actually sort of fill the need that existed. And so that was in summer of 2020. And then, so we worked sort of in that expectation that we're trying to make, a motion capture software for someone. And then in summer of 2021, I made a Twitter post that, showing me like juggling on a balance board and getting tracked by OpenPose and Deep Lab Cut, falling back on a history of posting viral videos to the internet. And it got a lot of attention, and people really liked it. And so since then, in the past, 6 months, there's been this kind of growing realization, for me and people in my lab and whatnot, that, this is something that people actually want. This is something that, and what we're doing is, on par with what is out there. Like, there's really, even like the paid versions of things are like really not that good, and they're really not doing anything differently than what we're doing. It's just a little more polished. It's kind of been this sort of growing realization that, incrementally sort of putting more and more effort towards this thing, and sort of incrementally realizing that the potential future of it is bigger and bigger, which is, exciting, intimidating, terrifying, mix of all those sort of fun feelings.
That was also honestly an awesome journey and story through that experience. It's so cool you mention your philosophy and sort of introspection, and I love how you reflecting on both your place in the world and how you contribute to it, and putting your work in the context of everything that's going on is just awesome.
The pandemic did a number on me for sure. This would have always been a strange time for me, like starting a professorship, moving to a new place. But I don't think that those introspective moments would have had quite the same impact if I had not been a professor, like if I'd still been a postdoc. Because when you're in academia, you're on temporary positions for pretty much the entire time, like undergrad, grad school, postdoc, those are all temporary positions. Then you become a professor, and all of a sudden you're part of the team. You're part of the institution. And when you're in academia, you have privilege, but you don't really have much power until you become a professor. And so I was sitting in that sort of that feeling of like, oh shit, I have power now. I was already kind of feeling weird about that, walking into it. And then all of a sudden it's like, and then everything else starts going down. And it's just like, okay, no, but really though, what am I going to do?
With great power comes great responsibility.
I love the MCU Spider-Man, but how are you going to drop Uncle Ben? For real.
Anyway, I know. Every time. So you talked a lot about the different open source softwares that are part of OpenPose and Deep Lab Cut that are part of FreeMoCap. I'm wondering, OpenPose is very known for being open. And what is the significance to FreeMoCap, and why not OpenMoCap or some other?
Yeah, and maybe too, I think you've talked a lot about the need for it, but maybe also overview of what it is exactly. I'm wait, do we really discuss what is the meat of FreeMoCap? Why is it different from other markerless motion capture softwares that are available right now?
Well, the nice thing about FreeMoCap is that it produces its own advertising. So if you just post this along with a video, everyone will know what it is before. So what it is, it's a free open source markerless motion capture system. So basically, it's designed to work with effectively any cameras, including like $20 webcams and GoPros. And we haven't used more expensive cameras yet because that was part of that shift that, around that sort of summer 2020. My plan at the time was use GoPros. And then when that works, shift up to more expensive research grade cameras. In that sort of shift, I was like, actually, let's see what the cheapest possible system. And it turns out that the floor on that is $20. Like if you pay less than $20 on a webcam, it doesn't work. I don't know why. I don't understand cameras, but we're working on it. But it's effectively a way to use, off-the-shelf hardware and open source software to achieve viable three-dimensional, what I'm calling research grade motion capture data, where research grade means that I would use it for my research. And so I'm a scientist, therefore it counts. So that's the hope, is basically the tagline is free motion capture for everyone, like using the tools that are becoming available through the advance of technology and being made available by open source groups like OpenPose, Deep Lab Cut, AnyPose, any of these folks. And basically trying to put them into a package that people can use. So back in 2017, I'm already a postdoc here, so I'm not untrained in anything, but it was incredibly difficult to get OpenPose running on my computer. I saw it and I was like, I need to use that. I need to figure out how to use it. So I went to their GitHub and I sort of tried to work through their instructions, and it was months. It was an effort of months to even get it running. So there's kind of this tension, right? Because there's all of these people out there, amazing groups. OpenPose, obviously a big one. Deep Lab Cut is another one that I've, sort of modeled my, early stuff after. And a lot of groups that are making these open source technologies based off of like these absolute future shaping tech that's coming down the line, machine learning, neural networks, convolutional neural networks, computer vision, what people sort of broadly call AI, but we don't use that term in this field because it's not specific enough. But there's all this amazing stuff that is available free and open source, but to use it, you need to have this incredible, there's a really high tech barrier to being able to use it because people make the thing, they throw it up on GitHub and usually just call it a day, which I now know, in retrospect, having worked on this for so long, I now know it's because making something usable by the general population is incredibly difficult. So right now, FreeMoCap is basically just a duct tape job where I'm taking all of these great tools that are online, that are available and free open source softwares and trying to duct tape them together into a package that is sort of usable and user-friendly and is accessible to people who don't have that kind of technical training, and ideally could serve as an inroad for people to get that kind of technical training. Because if you're going to use the thing, if you design the tool correctly, using it teaches you how it works. That's kind of part of the aspirational aspects of the current design process.
I like that philosophy of using it teaches you how it works.
That's the hope, right? And it's interesting because, talking about free software, free open source software or whatever. So in contrast, if you are selling a proprietary software, if your entire business model is, I'm going to sell you this software that does Markerless motion capture or whatever, and I'm going to support myself by putting a very high, 5-figure-ish price tag on it, you actually have a vested interest in ensuring that the people who are using your software never actually understands how it works. All of the core equipment, all the core software of biomechanics is just linear algebra. All these things are just massive GUIs to solve linear algebra equations. And yet they cost, $5,000 for a license or $23,000 for a license. And, all of these things can be done in Python or in MATLAB. Well, MATLAB's also not open source, but Octave. I think that that's one of the great advantages of being a free open source software is that I can commit to the design that whoever uses the software for long enough will learn how it works. I want you to understand every little bits and piece of it, but if I was trying to sell this thing as like a secret black box that does the thing that only I can do for you, I have a vested interest in the opposite. I don't want you to understand it. I want you to know how to use my tool, but I don't want you to know enough to be able to recreate it on your own.
Yeah, it's so interesting because I feel like a lot of the markerless motion capture systems, as you're saying, are quite challenging to set up and require an extensive background of coding as well. And it's hard because a lot of these are developed by scientists who do want to help and do want to make an impact and would love to see their project move forward into something that's usable. But I think there are some barriers to that, as in that sometimes these are PhD projects and then a person graduates and it doesn't continue. Is there funding to support translating this tool into, beyond just you publish the paper and then and then you upload the code to GitHub, but it's like, that's not really necessarily then someone's going to be able to download the code and put it together. It's so much more complicated than that. And having some really usable and simple tool to be able to do markerless motion capture, I could see could be really powerful. And I'm seeing that in one of my studies now, as we developed a tool to do that, just like a web app where people can upload videos and it automatically uses OpenPose to process it and gets results from that. And we've had so many people reach out and ask if they can use it. And it's like, when you get down to it, we're really just running OpenPose for them and calculating joint angles. But like, it's made me realize how hard that is for people. And it's hard for me too, to figure that out as well. So, and also with, where do you process these? You need storage space, you need security. It's like, it's a lot. Like, how do you manage all of this? And to me, it seems like a kind of an overwhelming.
You hit a couple really important things, I think, there. One is that, well, I'll talk about the second thing you said first. The structure of academia doesn't support these kinds of activities. We operate on the basis of students who are supposed to be, they're temporary. They're not allowed to stick around. They're supposed to move on and try to, be another one of you, even though there's not enough spots in the world to do that. And papers, they get, you publish them and then you walk away. And we really don't get rewarded for things like going back and making a GUI report, going back and cleaning up the code. Like, that's not, the gatekeeping dinosaurs above us on the hierarchy aren't impressed by that, because dinosaurs are never impressed by the future. They're dinosaurs. So there's a problem of like the activities that are necessary to make things usable are not rewarded. In addition, making things usable is really hard. It's very difficult to make something that anyone can use. And so there's a term in the software world of academic spaghetti code, which is the way that we tend to write code in the sciences. It's kind of this like discovery mode thing where like you start out like, I don't know if you can make this thing possible. And so you do the complicated thing and it does the thing and then you don't touch it. And that's how we do. And that's the scientific process. That's discovery. But to make the thing actually usable, it's a much longer and more challenging iterative process of, you take it, you thank it for what it taught you, you put it in the ground and you start over again. You talk to people who work in the tech industry, say, hey, what is best coding practices? You actually spend the time doing like the soft skills of, I'm doing air quotes for listeners, of like user interface design, user experience design. Like we in the sciences, we don't respect it because it's not fancy enough. And like, it's a challenge. So I don't know. If the question is, how do you do it? The answer is, I've never known what to do. I don't know. So it's mostly asking for help. The only way that I've managed to sort of take my weird, long, meandering path is to just kind of like look for the people around me that seem like they're doing the things that I want to do and then just copy them. So groups like Deep Lab Cut were really, they're like one of the few people. The technical capacity of Deep Lab Cut is impressive, but I think the reason why they've had the impact that they have is that they've built a GUI around it. I'll just say that GUI has a special place in my heart, but they did the effort to make it accessible to people that can't run code from the command line and can't write their own Python scripts. And so because of that, people use it. I saw them kind of trying to build that bridge between like high-level machine learning, computer science, and like biology, neuroscience kind of people, and started thinking that I kind of want to build that same kind of bridge, but instead of building it from like scientist to scientist, build it from like scientist to like general population, which is easier to do because I'm not actually making the tools. I don't know how. Like, I don't know how to do like the machine learning neural network stuff that it underlies these technologies. Like, I kind of know how it works, but I can't make it myself. I know how to use it. So that becomes the whole job, is like, how do you wrap these things in a package that is actually accessible to people that are not high-level computer scientists?
You're kind of the like Netflix of like just hosting. Maybe not Netflix, but
it's duct tape. I mean, it's basically saying it's like, okay, here's a cool thing and here's a cool thing, and I'm going to duct tape it together so that you can use it as a whole, as opposed to like having to use the pieces in their sort of in the form that they sort of are presented. Like because people present their stuff as usable as they can get it. And so then if I can sort of, me and my lab, if we can go in there and kind of figure out how to use it from that perspective, and then just like smooth that out, like build a user interface for it and make it so that, you don't have to, you can interface with it in a way that we recognize in like, GUIs and button clicks and whatnot. That's pretty good. The other question you're asking about like hosting and privacy and like longer term stuff, we will get to when we get there. I have friends who are sort of working with us now who are decade plus experience in like tech startup software development. So they know how that works. So I'll ask them when it comes up.
So you're not creating or training a new model. You're packaging these other softwares in a way that's accessible. How do you imagine, as there's multiple different markerless motion capture softwares popping up, they're improving and coming out with new versions, there's going to be a upkeep needed to keep that working. And I'm curious, I guess, for that in general, but then also as a free and open source software, how do you continue that upkeep and making it free to people?
So this is very much a long-term project for me. This is not a hit and run, drop it on GitHub and call it a day thing. I am thinking and planning. I formed the FreeMoCap Foundation nonprofit. We're trying to get 501c3 status, which is approved by the university and software disclosures and all that. But trying to think about the questions of like, how do you maintain long-term viability and like how do you keep afloat, especially considering what we just said about how like the standard trappings of academic science really don't support this kind of endeavor. One of the questions you asked is easy, about the different technologies and the different tools that are coming out. And that's actually always been sort of a core part of the project, is like we want it to work for all of those. Like we started with OpenPost, we've been using we switched to MediaPipe because it's a little easier to use, not quite as accurate, but much faster and easier to use. Deep Lab cuts in there to sort of like have like a train your own network. And there's a bunch of other options that people keep sending to me. And I haven't had time to integrate them yet, but the software is designed to sort of really focus on that sort of transition step I mentioned of like, okay, I'm going to see how your software works, and I'm just going to reshape it into the way that it needs to be to work with FreeMoCap thing. So that way, ideally, as new things come out, then it's just you write the wrapper, you write a little interface wrapper that says, okay, I'm going to take, all of them take in video and spit out pixel locations. Some of them try to guess 3D from one camera, but it's not very good. But they are coming out, they are getting better, and like who knows what the next big one is going to be tomorrow. And so the hope is to sort of have something that can interface with all of them and sort of provide avenues that way. The other question of, as a free software, how do you maintain viability? How do you get funding? How do you get money? That is a challenging question. And to that, I have done the thing that I like to do, which is look around at other people who are doing it and see what they're doing. There are plenty of large-scale open source projects. Blender, I've mentioned, Python, Linux, whatever, GIMP, FreeCAD, Inkscape. There's a ton of these out there. Alice Vision. So I basically stock all of them. If most of them want, NumPy, Matplotlib, like all these guys, I basically stock their tax records, stock their websites. A lot of them do annual reports. If they're a nonprofit, their taxes are public. Fun fact, any nonprofit, just Google name of the nonprofit, IRS 990, and you'll see how they get their money and where it goes. It also works if you work for a private university. And it turns out what most of them do is a mishmash of sources. You get some large-scale grants, small-scale grants. You can sell your services. Maybe you have maybe someday we start making our own cameras and we sell those. And so it winds up just being kind of like a patchwork network. And also I still plan to use this to do my research, and my research is funded by the NIH. So as long as they're like, hey, we like what you're doing, that was part of the kind of the thought process of this. It's like, I already live, as a research professor, I'm already expected to get enough funding to support a research program. And as I'm sort of looking at this, it's like, there's costs that are associated with this that are not associated with like standard academic research. But I'm already kind of trained in like how to get money. It's just a matter of like kind of shifting the flavor a little bit and sort of trying to continue to build a free open source software.
I just want to go back to one thing you said in there about filtering, or about, all these different people are coming to you and they're excited about this, which is awesome, and excited to have their software integrated with yours. I guess I'm wondering, what is the filtering process like? And do you feel that's your responsibility for, what are your thresholds for what's good enough to include? And also about, how do you be mindful about being inclusive? Probably want to incorporate all of these different, pose detectors that can do anything from, video analyses that can do anything from animals to humans to XYZ. Yeah. How are you doing that? And what are maybe some of the challenges there too?
So there's a lot of challenges. First of all, I was going to also just like for context of like the dream of FreeMoCap being like an easy to use thing is aspirational. We are not there yet. We're working in that direction, and we'll get there sooner rather than later. But that is kind of the goal. So in terms of that level of inclusivity, it's a continuous process. In terms of like vetting the potential algorithms that get included, there's a really nice sort of filter built in right now, which is like I really don't have the time to do that for most people. So, I think that there's futures where there's more time and more effort, more people working on this. But for now, we're focusing on just like core capacity. And for that, we're currently using AnyPose for the camera calibration. OpenPose is supported, but we're also using MediaPipe now, which is a Google project, which is cleaner, easier to use code. And then Deep Lab Cut is sort of under supported at this point because they haven't focused on it recently, but it's it's a build your own. You can train your own network so you can kind of track whatever you want. So the questions you asked will come up eventually, but for now we're kind of focusing on like the core capacity. Specifically now is like 3D motion, 3D full body hands and face of a human, accurate enough that like I as a researcher would look at it and think that's something I can do my science with. But you're not wrong. I mean, there's a lot of issues of inequity here. Like, any neural network based is biased on what it was trained on. And if it's a camera, then it can see things like your skin tone. So you must be really mindful of these. Yeah. So one of the nice things about MediaPipe is because it's a large scale Google project, that they have a section of the website about like skin tone and things like that. It's a legitimate concern. Good that people are looking into it. There's a documentary called Coded Bias on Netflix, which is nice. But also like at this point in development, like I'm not really in a place to be like changing the underlying algorithm. So there's a little bit of trust going on there that the people who are making them are kind of doing their best. Speaking of trust, I can't say trust and Google in the same word sentence. That's not a good idea. Like I am absolutely concerned about so here's the thing about Markerless motion capture. It's going to happen somehow, somewhere. Like we have the ability to track people accurately through cameras, and you better believe we're going to do it as a culture. Technology advances autonomously, and I absolutely am concerned about what FreeMoCap would look like if it was Facebook mocap. Like there are massive privacy concerns there. All I can really hope is that making a free open source version of this thing, which is absolutely going to be a technology that is a part of our future. Hopefully that will provide some sort of protection from a potential world where that technology is developed by one of these mega tech corporations who have proven time and time again that they cannot be trusted.
I appreciate your points about the inequities sometimes in machine learning models. And I've seen that in our study as well. We see women who are wearing long skirts, that it's having a hard time with that. Depending on people's weight, it is less accurate. And yeah, it's frustrating to see too as a researcher, but then knowing that we've only been training on this certain types of data. And now if you are able to create the software or a GUI or a way that we can more easily capture video and do markerless motion capture, then perhaps we can also start collecting more data. And I would hope that maybe those companies would then want to incorporate those and retrain their models and do things that are more inclusive, and we continue to improve in that way. So I appreciate the FreeMoCap will, I think, contribute to that potentially as well.
I mean, one of the things that I found really is helpful, but the only thing that's really helpful is when you're interacting with a new discipline that you don't know much about, to learn the culture of those researchers, what they value, how they choose their questions, what they consider an explanation, what does their data look like. And so as I interact with the computer science community, the research side of computer science that are actually building these algorithms, there's corporations aren't building the algorithms. These are being done by labs and then bought by corporations. That community is driven by benchmarks. Either you do something like an OpenPose where you come out like, hey, I'm doing something literally no one else can do. Most people don't do that. So what they do is they compete on benchmarks. And so you say, oh, well, I got 94, you got 94% on the COCO data set, and I got 95.6. And therefore I like a literal leaderboard and say there's in bold, and that's how that community considers progress. And so when you have that kind of methodology for establishing who works on what, it has these huge blind spots, because as a community of computer science they move really fast and they have no attention span. So like a lot of them kind of are acting like two-dimensional tracking is a solved problem because it's a little like, as the quote of someone, like it's a little too close to the pixels. They're always trying to scale up. Now they want 3D from 3D. Now they want volumetric tracking. Now they want faster. They want it to run on your phone. And they're not trying to make it more accurate. They're not trying to make it more inclusive. They're not trying, because, and I think the reason why is because they don't have, it's not obvious to them that that's a need. So I'm hoping one of them in the myriad of hopes around this project is that if, we can come up with definitive methods that say, hey, look, like on these metrics that matter, here's where you all stack up. If there can be like a quantitative measurement of those kinds of things, here's hoping that the people who actually have the capacity to drive that technology forward will start working on it, or I'll get the funding to hire the students.
Thank you so much for sharing all of that. This has been really interesting. We're really excited about the future of markerless motion capture and the ideas that you're posing. And we hope we do see, we're rooting for FreeMoCap in making, some these amazing technologies more usable, and having a team behind that is really exciting to hopefully push that forward. So where that Blender, which is a free and open source computer graphics software, has been a big inspiration behind FreeMoCap. And we've heard you bring up Blender a few times as you've been talking about us and the story behind FreeMoCap. So can you share a little bit more about that inspiration and then this connection between human movement and 3D animation, which is Blender?
So Blender has been, one of the people I like to sort of pretend to copy. I think that, my interest in them comes from kind of twofold. One is like what Blender is and what it can do. So basically, like if you look at like an animation, you look at like, Toy Story or whatever, 3D animated movie you want to look at, what you're looking at is artists who have used a GUI to have an incredibly fine-grained control over minute aspects of 3D space, which is an incredibly powerful thing that, I've been trying to do that from like code and sort of raw level linear algebra for years. And it's knowing things at that level is very valuable, but it's limited. There's only so much you can do. So I think that having the tools that are available to animators, available to scientists, will make scientists better scientists, and will also connect that artistic side of technology and 3D animation to the sciences and biomechanics that are happening. Other thing that's inspiring about Blender is that it is a great example of a large-scale free open source software that has its own legs and is growing in really interesting ways. I look at that and I think of that sort of large-scale collaborative endeavor with like an actual end goal project that is usable and useful for the general population, and I see that as like that's a better model for science. That is how we should be doing science. I think the open source community is what science and academia pretends to be. Like we are actually very siloed. We don't really work well together. We don't work on large scale collaborative projects. We do papers and piecemeal stuff because we're all fighting for survival in a world. So Blender has been a particular inspiration, both because of the capacity that it affords and also for what it represents.
And again, it's been so nice to hear that echoed throughout this conversation, like not only the awesome technology and accessibility, things you're doing to make it more accessible, but also the thoughtfulness and intentionality that you have behind it. And I think that is a little bit on that artistic and creative side, like in your philosophy. And like, I don't know, it's just been really awesome to kind of go in and out of all those different perspectives in this conversation. So we've really enjoyed it and enjoyed talking with you.
If people want to learn more about your work or more about FreeMoCap, how can they do that?
So we have there's a lot of ways. FreeMoCap.org is the website. Twitter is the thing. So twitter.com/FreeMoCap is where I do most of my communication there. There's also FreeMoCap accounts on Twitch. There's a Discord server that you can get to through the Twitter, the website. I don't know. So you can find all these things. So the website, we got Twitter, we got Twitch. There's technically a TikTok, but I don't use it very much. There's a Facebook page, an Instagram, and I think there's a subreddit.
If you want to send us those links, we'll add them all in the description so people can find them.
Well, thank you so much, Jonathan. This is amazing and a great way to start our day.
Well, thank you so much for the conversation. It was a lot of fun.